Okay, we're going to make a start now. So welcome everyone to our GCSE Maths session. In today's lesson, we are going to be looking at circle theorems. So we're going to have two lessons on circle theorems, one this week and then one the week after next week. Okay, in today's lesson, we're going to introduce the rules and we're going to be looking at some simple exam questions. And then we're going to get slightly harder towards the end of the lesson. In our next lesson on circle theorems, we're going to be looking at sort of the harder type of circle theorem questions that you can get, along with algebraic circle theorems. Um, but that will be the lesson after the next, where we will be looking at algebraic circle theorems. Okay, at any point, if you have any questions, feel free to let me know in the Q&A. We're going to start off by looking at the rules, and then we're going to move on to some exam questions, and then to finish off, we're going to have a blocklet at the end of the lesson. Okay, if you don't have access to the Q&A, you can scan this QR code, which is on the screen. And if you have any questions, you can ask me by typing in your question in there. So we're going to start off, and with circle theorems are basically rules that you need to know. And with circle theorems questions, you will normally be asked to calculate the size of a specific angle. And if you know these rules will help you calculate the size of any unknown angles. That's what circle theorems are there for. You will basically have like a triangle or some sort of lines inside a circle, and you will have to calculate the size of some specific angles. Okay, and there are six rules that you need to know, and that's what we're going to go through. And then we'll move on to some exam questions and the reasoning that you need to give in exam questions to get the maximum amount of marks. Okay, so to start off with, we've got this rule. Okay, and this rule basically says that the angle at the center is twice the angle at the circumference. Don't get them the opposite way around. The angle at the center, which is this red angle that I've drawn, will be double the angle, which is here, at the circumference. Okay, so whenever you see this shape appearing within a circle, I might have an exam question on that, like this sort of shape. Whenever you see a shape like this appearing within a circle, you know that this angle, which is at the center, the angle that they've given you at the center, it will be double the angle that is at the circumference. Okay, that's the first rule that you need to be aware of. Okay, so in this diagram that you can see over here, we can see that the angle, which is over here, the circumference, which is angle A, that is double the angle, which is, sorry, that is half the angle which is at the center, because the angle at the center is twice the angle at the circumference. Don't get them the opposite way around. Many people go wrong by getting that the opposite way around. So try not to get that the opposite way around. It's really important that you remember the angle at the center is twice the angle at the circumference. Okay, and whenever you see this shape in a circle being drawn in an exam question, you know that this rule is straight away going to apply. Okay, so that's the first theorem. That's the first rule that you need to be aware of. Now, the second rule you need to be aware of is angles in a semicircle. The angle which is in a semicircle is 90 degrees. So basically, when you have a triangle that is sort of contained within a half of the circle. So over here we have a triangle that is contained within half of the circle. We can see that it's only taking up half of the circle. The angle that you can see there that is in contact with the circumference will be a right angle. So if I drew it out again, let's say I had this circle, and let's say I had was my diameter, and then I drew a triangle like that. This angle would be 90 degrees, because this triangle is contained within half of the circle. So triangle is contained within half of the circle. Okay, and that's what you need to be aware of. Whenever you see questions where you've got a triangle that is only taking up half of the circle, this rule is going to apply. The angle in a semicircle will be 90 degrees. Okay, and the hypotenuse, when we're talking about the hypotenuse, remember it's the longest side that is in the triangle. The longest side will be the diameter. Whenever this one of the sides is the diameter, this is the diameter, as you can see. Whenever one side of the triangle is the diameter, the angle which is opposite the hypotenuse is going to be a right angle. Because again, when we look at the rules of Pythagoras' theorem, we know that C is the longest side and it is the side which is opposite to the right angle. Okay, so just like that, D is the diameter. Diameter is taking up one side of the triangle, and all the triangle is held within one aspect of the circle, within half the aspect of the circle. Okay, so it's contained within the semicircle. Okay. So those are the first two rules. Now I've ordered these rules in a way that they start off slightly easy and then at the end you get the hardest rules, okay? But again, it's really important to understand the hard rules because those are the ones where exam questions are most likely to be asked. Okay, so these are the first two rules that you need to be aware of. The angle at the center is twice the angle at the circumference. That's the first rule. And then angle in a semicircle is 90 degrees. That's the second rule. Now, the third and fourth rule is as follows. Again, the top rule is pretty much straightforward. Whenever you have like a quadrilateral, remember a quadrilateral is a four-sided shape. Whenever you have a quadrilateral present within the circle and all the corners are touching the circle, so as you can see over here, A, D, C, and B, all the corners, they are touching the edges of the circle. That's what you call a cyclic quadrilateral, a quadrilateral which is placed within a circle. Okay, so a quadrilateral is a four-sided shape. And when you've got a four-sided shape which is placed within a circle, all that means is that it has become a cyclic quadrilateral. Okay, and the rule about this that you need to be aware of is that opposite angles which are present in a cyclic quadrilateral, they add up to 180 degrees. Okay, that's the key rule that you need to be aware of. So over here, if you had angle A and angle C, both of these angles, because this is a cyclic quadrilateral, a quadrilateral which is inside a circle, both of those angles, they need to add up to 180 degrees. And just like that, D and B are opposite to each other. Because angle D and angle B are opposite to each other, those two angles also have to add up to 180 degrees. Okay, so if I drew you another shape over here, we've got a circle, and then we've got a cyclic quadrilateral. Okay, this is a cyclic quadrilateral because all the corners are touching the edges of the circle, as you can see. Opposite sides, opposite corners must add up to 180 degrees. So this angle and this angle must add up to 180 degrees, and then this angle and this angle must add up to 180 degrees. So if you know the size of one of the angles, then you can work out the size of the other angle because you know that the opposite ends have to add up to 180 degrees. And that's the rule about a cyclic quadrilateral, which you need to be aware of. Now, the next rule is about a tangent. Now, a tangent is basically a straight line which meets a circle. So if we had something like this, let's say we had a circle over here, and then we've got a straight line that doesn't really intersect the circle, so I'm going to draw it again. Okay. So let's imagine we've got a circle like this, and this time we've got a line which is just touching the circle and it's going. This line is called a tangent because a tangent is just a straight line which touches the circle at one distinct point and then carries on going. That's a tangent. Now remember what a radius is. When you've got a circle and then you've got a center and then you've got a center and a line being drawn from the center to the edge of the circle, that is known as a radius. Now, the rule that you need to be aware of here is, let's say we had a radius and that radius touches the tangent. When that radius touches the tangent, the angle which is created is 90 degrees. Okay, so this angle is 90 degrees. Okay, so when a radius meets a tangent, the angle which is created is 90 degrees. That's what the first rule says. The angle between a tangent and a radius is 90 degrees. Okay, and then the next rule about tangent which you need to be aware of is that tangents which meet at the same point are equal in length. What does that mean? So basically, when you've got two tangents going to a circle, if they're coming from the same length, same point, let's say you got another tangent like that, that means that both of these tangents, they will be equal in length. Okay, if we draw another radius over here, this length that we have over here, this length and this length, they will be both equal because the tangent is meeting the radius and both of the tangents, they are coming from the same point. So when they arrive from the same point, they are equal in length. Okay, so just to recap, we've got a cyclic quadrilateral. All that means is you've got a four-sided shape, a quadrilateral sitting inside a circle. And all the corners of the quadrilateral, they are touching the edges of the circle. So as you can see, you've got a point here, A, B, C, and D. Okay, so as you can see, we've got a four-sided shape and all four corners, they are touching the edges of the circle. Okay, now in terms of a tangent, we know that a radius is half of the diameter, and a radius comes from the center of a circle and it meets the circumference of the circle. Now, when a radius meets a tangent, remember, tangent is just a straight line which touches the circle at one point. When a radius meets a tangent, the angle which is formed is 90 degrees. Okay, and then when you've got two tangents on a circle and both of the tangents, they are coming from the same point, like here. When they're coming from the same point, that means the length of those two tangents will be exactly the same. Okay? And if they're meeting a radius, the angle which is created will also be 90 degrees. So we've looked at these two. Angle at the center is double the angle at the circumference. The angles in a semicircle is 90 degrees. Remember, it's just a triangle that is taking up half of the circle. We've looked at the rule of a cyclic quadrilateral, and we've looked at the tangent rules in a circle. If there's any of them that you don't quite understand, please do let me know in the Q&A and I can go over them once more. Now, there are two more rules which I am going to go through, and these two are probably the most difficult circle theorem rules that there are. Now, the first rule is the alternate segment theorem. Okay, and you don't need, whenever you're explaining these rules, you need to basically write an explanation after you've got your answer. So with circle theorems questions, the questions are normally worth around 4 marks, 4 or 5 marks in an exam, and the marks will come from your answers and it will come from the explanation that you are giving of how you got to the final answer. For the alternate segment theorem, you don't need to explain anything. You just need to write down alternate segment theorem. That's the rule that you used to get to the final answer. And this will make more sense when we look at some exam questions. But in terms of the alternate segment theorem, this is probably the most complex rule that you could be faced with. What this is saying is that when you have a tangent that is meeting a chord, so this is an example of a chord, the difference between a chord and a segment is the larger part. So we know if I draw a circle over here, let's say I just drew a line over here. just like randomly in the circle. This smaller part is known as a chord. This is a chord. And this larger part is the segment. Okay, so you have a smaller chord and then you have a larger segment. So when you're referring to the large part, that's the segment. When you're referring to the small part, that's the chord. Okay, and what this is saying is that the angle in the smaller circle where the tangent is meeting in the chord, that will be the same as the angle in the alternate segment. Okay, so we know that this aspect over here is the chord. This is the chord. What this is saying is that the angle which is made in the chord, this red angle that I have drawn, that will be the same as the angle in the alternate segment. So it will be the same as the angle which is in the alternate segment. We know that the segment is the bigger part, and we can see that the angle in the alternate segment is this part over here, this angle over here. So both of those angles will be equal to each other. In order to understand this rule, you need to understand this, what a segment and what a chord is. And just imagine, let's say if I drew you another example, and we'll look at some exam questions with the alternate segment theorem. Let's say I just draw a random line like this, okay? The smaller part, this part, is known as the chord, and this large part is known as the segment. And what this rule is telling us is that the angle which is by the chord, which is the smaller part of the circle, this angle over here, it will be the same as the angle which is in the alternate segment. So the alternate means the other, and segment is the larger part of the circle. So the other segment, the other large part of the circle, and the only angle that we can see is this angle that I've highlighted in red. So both of those angles will be the same. That's what the alternate segment theorem states. Okay, and then we have another example over here. It says angles in the same segment theorem. Okay, that's the rule of this. Okay, what this is saying, the angles in the same segment are equal. Okay, so remember, over here we have a dotted line, over here a dotted line drawn between D and B. What this is saying is when you have angles that are in the same segment, over here we can see these two angles are in the same segment, they are next to each other, both of those angles will be the same. Likewise, this angle over here, angle D, is going to be the same as angle B, because both of them are opposite to each other and they are also in the same segment. Okay, these two rules are the ones which many people find difficult to explain and very difficult to sort of notice with circle theorems. But the main aspect that you need to be familiar with is this over here. Understand what a segment is and what a chord is. If you understand this concept properly, then you will understand both of these circle theorem rules effectively. Okay, the chord is the smaller part in a circle and the segment is the larger part in the circle. Okay, think of it like that. The chord is the line that you draw, and if you think about it, the bigger area, that's the segment that they're talking about in circle theorems. Okay, so this angle over here that is bound by the chord and the tangent will be the same as the one in the opposite segment. The opposite segment is in the other area, the other part of the circle. And over here, you have a segment and then you have a smaller segment. The areas are called segments. The line is called the chord. You have a bigger segment and you have a smaller segment. Okay, so this is the bigger segment. This is the smaller segment. Segment just means part. Like if you're eating pizza, if you take a slice of pizza, that's a small segment. And then the pizza that you have remaining, that's the bigger segment. Okay, so these are the 6 rules that you need to be aware of in terms of circle theorems. In terms of exam questions, you won't be given the rules. You will have to use your knowledge of the rules and see if you can spot what rules applies where. Okay, that's the tricky part about circle theorems. That's why many people find circle theorems tricky. Okay, and we're going to move into some exam questions, and I'm going to get you guys to spot some of the rules which are occurring. Okay, so we're going to start off sort of simple and then build on. And then in our next lesson on circle theorems, the week after next week, is going to be based on tougher circle theorem questions and algebraic circle theorems. Okay, so here's our first question. So what rule do you think is being applied here? And how would you answer a question like this? Okay, I want you guys to have a go at it. Okay, and tell me any rules that you can see. And rules such as angles in a triangle add up to 180, angles in a circle add up to 360, those also play an important role as well. You have to write those as rules as well. So I'm going to give you guys a couple of minutes to have a read of this question and have a go at it. Once you have an answer, you can type your answer into the Q&A, but I'm going to go through this one in about a minute or so. Yep, I can go back. I'll give you 30 seconds and then I'll move back to the question. If you'd rather, you can take a screenshot of it and then copy it down in your own time, if that's any better. Okay, going back to the question. Okay, in terms of in holidays, we've not actually decided whether we are taking lessons, but we will confirm that closer to the time. There will be a lesson next week, though. Okay, so I'm going to start going through the answers now. So it says B is a point on the circumference of a circle, center O. Don't worry if you didn't get this straight away, because it takes practice. So we know that B is a point on the circumference. Circumference means edge. Okay, so B is a point on the circumference of a circle, center O. AB is a tangent to a circle. Remember, a tangent is just a line which is going and it's meeting the edge of a circle. So this line over here is a tangent which is meeting the circle. Okay, now we can see that OB is the radius to a circle. Okay, we can see that O is the center and it's touching the circumference of the circle. So that's a radius. And remember, when we look at the rules of circle theorems, we know that when a radius meets a tangent, the angle which is created is 90 degrees. So this angle which is created is 90 degrees. Okay, so we know that because of our rules of circle theorems. And then we need to calculate the size of angle BAO. So B to A to O, we want to calculate the size of this angle. So we need to give an explanation for each stage of our answers. And this is vital because when we get into harder questions, 4 and 5 markers, algebraic circle theorems, it gets much more complicated. So you need to get used to giving your reasoning for each stage of your answer. Okay, so what did we use first? We saw that we had a radius over here and it was meeting a tangent. And if we go back over here, we know that a radius meeting a tangent at 90 degrees. The angle between a tangent and a radius is 90 degrees. That's the rule that we are using. So we're going to say that an angle, sorry, not an angle, a tangent meets a radius at 90 degrees. Okay, that's the first thing that we noticed with this question. Now we need to calculate the angle BAO. Now, how do we do that? It's a triangle. So we know that angles in a triangle add up to 180 degrees. That's the second thing we're going to use. So angles in a triangle add up to 180 degrees. So we know that this one is 72. We know that this one is 90. We just need to work out this one. So 72 add 90, if we work that out, that's going to get us an answer of 162. And then we're just going to do 180, subtract 162, and that's going to get us 18 degrees. Okay, so the answer to this question will be 18 degrees. Reason being is our explanation. We saw that a radius was meeting a tangent. We know the rule is that when a radius meets a tangent, the angle formed is 90 degrees. And we also know that angles in a triangle add up to 180. So we added all of them together and they should get us 180. That's how we got to the answer of 18 degrees. Okay. So this question we've actually already sort of been through. We can see over here, we need to find the angle sides of BAC, this angle over here. That's our unknown angle X. Now, straight away, we can see that shape being formed. We know the angle at the center is going to be double the angle at the circumference. So angle at the center is double the angle at the circumference. Okay, we know that this is the key rule. Angle at the center is double the angle at the circumference. So if this is 66, we know that this is double the angle which was originally here. So this must be 33 degrees because the angle at the center is double that angle. So that angle is going to be 33 degrees. It is double the angle at the center is double the angle which is at the circumference, and double 33, that gives you 66. Okay, now we'll come back to this question. The only reason is because that's a bit more advanced, but again we'll go through it. So I want to go through this question first. So I'll give you guys an opportunity to have a go at this. So have a go at it. Type your answer into the chat once you've had a go at it. I'll start going through the answers in a couple of minutes. Okay, so I'm going to go through the answers now. So it says A, B, C, and D are points on the circumference of a circle. Angle CAD is 62 degrees. Angle ADB is 51 degrees. Find the size of angle ACB. So middle letter C, so it's ACB, this one over here. Now, what does this look like? This rule looks a bit like the same segment rule that we looked at. Now, the best way to think about it is we can connect these 2 points up. Okay, and when we connect these 2 points up, we've created 2 segments. We've created a smaller segment and we've created a bigger segment. And the line which is connecting these 2 up, those 2 angles are going to be the exact same. So 51 degrees, this one's going to be 51 degrees. And if this is 62 degrees, then this one is going to be 62 degrees. Okay, because they're in the same segment. Okay, if they're opposite to each other, opposite angles in the same segment will be equal. Okay, the line which is connecting those 2 corners together, those 2 angles will be equal because they're in the same segment. You could have drawn the line this way over here as well. When you draw the line this way, you can see that these 2 angles are in the same segment. Because they're in the same segment, both of them are going to be equal. They're going to be both 62 degrees. So ACB is going to be 51 degrees. The reason why is because angles which are in the same segment are equal. So angles in the same segment are equal. Okay. Okay. We'll have a look at this one. So again, have a go at this one and type your answers into the chat, and then I'll start going through it in a couple of minutes. Okay, so I'm going to start going through the answers now. So it says find the size of angle ABC. Okay, now the way that you find the size of the angle, so what does this look like? This looks like a quadrilateral, which is inside a circle. Because this is a quadrilateral within a circle, you know that opposite angles in a cyclic quadrilateral, they add up to 180 degrees. Okay, so the reasoning would be opposite angles in a cyclic quadrilateral add up to 180 degrees. Okay, now it says find the size of the angle ABC. That's this angle over here. Now that's x. We know that this one is 83 degrees. Now because this angle is 83 degrees, we know that this one and this one together must make 180 degrees. Okay, so something at 83 must give you 180. So you do 180 subtract 83, and 180 subtract 83 gives you an answer of 97. Okay, so your answer is going to be 97 degrees. Okay, now we're going to go back to this question. Now in this question, this is a slightly sort of more difficult question, and the way that you answer questions like these is sometimes to make it easier in terms of the circle theorems question, you have to draw lines on the diagram yourself. So over here, we can see a center, we can see two tangents. Now we know when there's tangents, if we draw ourselves a radius, we know that the angle which is going to be formed is going to be 90 degrees. So to make our life easier, what we can do is we can draw a radii for ourselves like this, radii, because if we draw a radii for ourselves, we know that when a radius meets a tangent, the angle formed is 90 degrees. So we know that this will be 90 degrees. And when this radius hits this tangent, this angle will be 90 degrees as well. So using that knowledge, I want you guys to have a go at this question and the reasoning for the answers. And then I'm going to start going through it in a couple of minutes. Okay, just one more minute, and then I'm going to start going through the answers. Okay. So going through the answers now. So it says B and C are points on a circle, center O. AB and AC are tangents to the circle. We know that BAC equals 40 degrees. So if we label that the middle letter A, B to A to C is 40 degrees. So this angle over here is 40 degrees. Work out the size of the angle BOC. Now BOC is this angle over here that we need to work out. Now, how many sides do we have? We have a four-sided shape over here. Okay, so we have one side over here, one side over here, one side over here, and one side over there. We have a four-sided shape. And we know that angles in a four-sided shape add up to 360. Okay, so first of all, what rule did we use? We drew our radii and we said that a radius meets a tangent of 90 degrees. So a radius meets a tangent at 90 degrees. And the rule that we are using now is that angles in a quadrilateral, they add up to 360 degrees. So angles in a quadrilateral add up to 360 degrees. So we know that 90 at 90 at x at 40, that must be equal to 360. Okay, 90 at 90 is 180. 180 at 40 is 220. 220 at x equals 360. So that means 360 subtract 220 equals x, which is equal to 140. So x is equal to 140 degrees.